Welcome back to the Sunday Python School. In this session, let's move on to see the 4 stages of application development. When you recall the computer games which you used to play maybe about 15-20 years back, we find that those applications, even though you were very interested in those applications, you do not have them on your system today. Why is that so? Because that was the first phase of application development where the application was designed to live and die on one operating system. Then came the second phase of application development where people started developing an application, and once that application was kind of sold out, what they did was they went on to develop the same application on a different platform. So the same team were trained to work on a new programming language, on a new platform, on a new operating system, if you will, and that was phase 2 of application development. Then came phase 3 of application development, where the application, even before the application development started, we checked out what is the programming language available on multiple platforms. After finding a programming language available on multiple platforms, people started developing the application on a platform and then ported the application to the other platforms. This is the concept of porting. Today, we have grown beyond this. Today, we talk about cross-platform application development. And what is this supposed to be? You develop the application on a platform, and the same application is being used on multiple platforms. So here what happens is, one hard disk is shared between different operating systems. On the Windows operating system, we have the concept of mapping a drive. On the Unix operating system, we have the concept of network file system. So the same hard disk is being shared between different platforms. When you look at Python, Python is a cross-platform programming language, which means you develop the application once and then you are in a position to use the same application on different platforms. Having said that, when you're talking of cross-platform application development, the cross-platform application needs to stand up to the demands of the operating system. Going forward, we will see how you can query what is the operating system you are currently executing this application on, and then you will be in a position to execute the appropriate command for that operating system. If you're working on the Windows platform, we know that we need to clear the screen using the cls command. On the Unix operating system, the cls command does not exist. It is the command called clear to clear the screen. So you can, in an if and else, find out which is the operating system on which you are currently executing the application, and then based on the operating system, you can execute the appropriate command. That is about the 4 stages of application development. Let's go on to understand the 4 generations of programming language. When you talk about the 4 generations of programming languages, to start off, we had the first generation programming language where you had to write the entire program using either a 0 or a 1. The machine language, the first generation programming language, if you are one of those writing a program in machine language, you'd find that if you made a mistake, it was better to rewrite the entire program than correcting the program. That was the first generation programming language, the machine language. The second generation programming language focused on control of hardware without using zeros and ones. That is where your assembly language fits in. Then came the third generation programming language, where the focus was on simplicity. For example, the C programming language. You don't need to know the programming language to understand what the program is doing. For example, printf, I don't understand what the F in the printf is, but print I know is writing. Similarly, scan is doing reading. Scan is doing the reading. So when you look at the third generation programming languages, the focus was on simplicity. When you look at the fourth generation programming language, the focus is on spoken English. So when you're working with Python is a fourth generation programming language. It is a cross-platform programming language. When you read a program written in a fourth generation programming language, you will be in a position to relate to it very quickly. Immaterial to whether you are coming from a programming background or not coming from a programming background, you'll be in a position to understand the program, and that is the simplicity with which a fourth generation programming language comes into the industry. Python is a fourth generation programming language. Python is a cross-platform programming language. Python is also a purely object-oriented programming language. And what does that mean to you? Let us try and understand. When we talk about Python being a purely cross-platform, purely object-oriented programming language, let us try and understand what this means. To start with, let's execute the Python command. This will take us to the Python interpreter. The triple greater than is the Python interpreter. This is the Python interpreter prompt. It is triple greater than space. Now it is at this prompt that you are going to execute your Python commands interactively. Moving forward, we will also see how we can write our own Python scripts. When I say that Python is a purely object-oriented programming language, what does it mean? Let us try and understand. If I happen to give an x is equal to 10, this creates an object x. And when I give a y is equal to good morning, this is creating an object y. This is creating an object y. Some of you may be thinking, he's just playing with words. He's created two variables and he's calling them as two objects. Now let us try and understand what we have. An object has attributes and methods. Those of you coming from the object-oriented programming language appreciate the concept of attributes and methods. So now let us go on to see if the x and the y have their attributes and methods. To find out if they have the attributes and methods related to the object x, give dir in brackets x. To find out the attributes and methods of the object y, give dir of y. These are the attributes and methods of x, and these are the attributes and methods of y. So when you're working with Python, when I say these are the attributes and methods, we see that there are some similarities and there are some differences too. The double underscore abs double underscore does not exist here, but the double underscore add double underscore exists here. So there are some similarities and there are some differences. Now let us go on to learn how to get help with respect to this object x. So when I give help of x, it is giving you help on int object, class int in brackets object. If you want to go to the next screen, you can hit the space bar. If you want to go to the next line, you can hit the enter key. If you want to quit out of the help, you can give a Q for quit. So this has come back to the triple greater than prompt. When you execute help of y, it is giving you no Python documentation found. Now let's go on to learn how to get help on an object of type string. So you can give type in brackets y to find out what is the class to which y belongs, and then you can execute help of str. Now you're able to get to see help related to the string class. Let us see what we have here. If you scroll up and have a look at these symbols which are here, you see that there is a double underscore abs double underscore, that is a double underscore add double underscore and a double underscore. Observe this. Here you have a double underscore abs double underscore add double underscore and double underscore. All those symbols, what you are seeing in dir of x or dir of y, you'll be able to get in help of x and help of y. So let's come out of help here. Let's come out of help by giving a Q for quit. Let us execute help without anything in parentheses. When you give help without anything in parentheses, observe it is giving you welcome to Python's version numbers help utility. In this, if this is your first time using Python, you should definitely check out the tutorial on this particular link. Enter the name of the module, keyword, or topic to get help on writing Python programs and using Python modules. Here is something you have which is interesting to you, that is to get a list of available modules, keywords, symbols, or topics. Type the appropriate word. So to start with, let's type in keywords and let us see the list of keywords. When you look at this list of keywords, let us try and understand what you're seeing. These are the most commonly used words which you'll see. Keywords in Python cannot be used as symbols, meaning you cannot create variables or functions out of this. So going forward, you'll see examples where you'll be working with it. So let us see what we have with some of the symbols listed here. You have the if, you have elif, else. So that is your construct if, else, elif. You have the while loop, you have the for loop. Whenever you're talking of loops, you talk about break and continue. To create a function, you use def to define a function. To create a class, you have a keyword called class. You have true and false here, true and false. Those are the Boolean values. What is none supposed to be? We will explore when we come to functions. So these are some of those keywords which we have explored. So this is the complete list of keywords. Now let's go on to see what we have with symbols. The operators for addition, subtraction, multiplication, division, comparison, all these operators are listed here. If there is any symbol which is supported on Python, that symbol is listed in this list of symbols. Observe here, you have the less than, you have the less than or equal to, you have greater than, you have greater than or equal to, you have double equals for equals, and you have exclamation equals for not equals. Apart from this, you have the plus for addition, you have the minus for subtraction, you have the slash for division, you have the star for multiplication, you have percentage for modulo. So these are your arithmetic operators. You have other operators too. So you have a host of symbols which are listed. If there is a symbol supported in Python, then that symbol is listed here. Let us go on to see what you have with modules. When you talk about modules, let us type in modules and hit the enter key. Let us type in modules and hit the enter key. It shows you a list of modules. These modules not only include the modules which you have created, which are installed when you install Python, it also has modules which you have created. So you may find some of those modules which I have created listed here. So here are your list of modules. After this, you have topics. Topics, observe, they are all in capital case. This topics is a list of topics related to help itself. If you recall, you had modules, you have typed modules in uppercase, and it had given you the list of modules. And here is the modules, and it is giving you help on how to create your own module and so on. To come out of help, you can just hit the enter key and you'll come back to the triple greater than prompt. You're now leaving help and returning to the Python interpreter. So you're back to the triple greater than prompt. So you have seen x is equal to 10, y is equal to good morning. You have given dir of x, dir of y, help of x, type of y, help of str. And then you have seen help without anything in parentheses. Now, let us go on to give help. We have given help without anything in parentheses. Let's go on to give dir without anything in parentheses. So here we go with dir without anything in parentheses. Apart from other things, observe that it is giving you the x and the y, the two objects which you create. Well, the focus of this particular execution more than the x and the y is about the double underscore built-ins double underscore. So here is a list of built-in functionality which you have. When you look at the list of symbols listed here in the dir of double underscore, built-ins double underscore, and the list of keywords and the list of symbols, these three put together is core Python for you. Meaning, if I have this, I don't have to import any module at all. I don't have to import any module. I can simply work on Python prompt and I don't have to import any module. Let us move on to explore how we can read from the keyboard and write to the monitor. To read from the keyboard, we use the input function. So let us give name is equal to input. Name is equal to input. Enter your name. Enter your name. When I execute this, it is going to give me this prompt, enter your name at the bottom of the screen. So here I am typing my name and hitting the enter key. Now I need to find out if it is actually stored in this variable called name. So what do? I do print. Let's say without just printing the value of the variable, I also want to give a message. So you are comma name. This is giving you, so you are followed by the name which I entered, my name, Khabib. This is how you can read from the keyboard and write to the monitor. Now, let us go on to learn how to write a script. To write a script, what I will do is, I will pick this up as it is. I will pick this up as it is. I have copied it. Let me get back to the command prompt and let me open this in a notepad. When you're learning, it is better that you work with notepad. The reason being, when there is IntelliSense, it is going to do a lot of spoon feeding. It is going to, if you type the word A, it will give you all the words starting from A. So it is better that you avoid working with any of the IDEs like Spider, PyCharm. Well, in your projects, it is better that you use all these IDEs and high-end tools. But when you're learning, it is better that you work with Notepad so that you do the thinking and you do the typing. So I'm giving Notepad, and with Notepad, I'm giving, let's say, input underscore print dot py. All your Python scripts should have .py extension. Apart from that, all your Python scripts should also have hash exclamation /usr /bin /python3. This is necessary for the Unix operating system when you're executing a Python script on the Unix operating system. And the .py is necessary when you're executing the same Python script on the Windows operating system. On the Windows operating system, we have the concept of associating an extension with an application. So the .py is associated with a Python interpreter. So now, whatever I have copied from there, I am pasting it here, removing this prompt and the output. So here is my script. I am closing this. I have saved the file. Now I'm executing this program and I'm repeating the same. I am entering my name and hitting the enter key. It is giving me, so you are Khalid. So we have successfully written our first Python script. Now that we have understood how to write a Python script and execute it, let us go on to explore some basics when you're working with Python. Working with Python, we need to understand that Python, being a fourth generation programming language, you will be able to relate to Python. Let us see what we have. Let us go on to do some arithmetic. 10 plus 20. It is giving me 30. 10 divided by 20. It's giving me 0.5. 10 minus 20 gives me minus 10. 10 into 20 gives me 200. 10 percentage 20. This percent sign is modulo. Modulo means reminder. So when I give 10 percentage sign 20, that is 10 mod 20, it is giving me a value 10. This will be the reminder if I divide 10 by 20. Whether I give 10 by 20 or any big number 10 mod 20, it is giving me the same 10 because that will be the reminder when I divide that number by 20. Let us do a 3 double star 3. Observe that this is the same as 3 into 3 into 3. This is 3 power 3. This is 3 power 3. Observe, it is giving me 27. The double star is the power of operator. When we executed symbols in help at the help prompt, you got to see a host of symbols, and in that list of symbols there are many more arithmetic operators. So you can explore that moving forward. Let us try something. Let me give 9 double star. It's giving me a 9-digit number. It's giving me a 9-digit number. This is 9 power 9. If I happen to give double 9, double star, double 9, this is giving me a very big number. This is giving me a very big number. Now let's go on to see if 999 double star 999 also works. Observe that this is also working. The moment I hit the enter key, it is giving me the result. Now I'm giving 4 nines double star 4 nines and hit the enter key. The moment I hit the enter key, it is giving me the result. Let me give 5 nines double star 5 nines. Observe, this will take some time before it comes back. Now this does not mean to say Python is slow. Why would I say that this does not mean Python is slow, even though it is taking such a long time there? I am converting this to a string and finding the length of this string. Let us see what we have. Sorry for the spelling mistake. Let us see what we have. It is doing its calculation and it is giving me the length. This is 5 less than 500,000. So what we need to understand is this is a very, 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 very large number when it comes to a number so huge. Python was able to do the calculation. Python is a no limits programming language. Even if there are limits, the limits are so huge that you cannot consider them as limits at all. Even if there are limits, the limits are so huge that you cannot consider them as limits at all. In the process of executing this, let us try and understand what I have done. We have used a function called len and another function called str. So now what we will do is, we will go and find out where these functions are coming from. If you recall, we did a dir of double underscore built-ins double underscore. In this, from ABS to zip, all these are your built-in functions. Let us see some of the built-in functions which we have used so far. You have used the dir function. You have used the help function. You have used the help function. You have used the len function. This is your len function which we just used. We have used a function called input, and we have also used another function called print. of course, we have used the type function also. So these are some of the functions which we have used. These are your built-in functions. Let us move on to see some comparison operators. When you're talking of comparison operators, let me take you to the help prompt and show you in the list of symbols what are the comparison operators which you will commonly use. You have the less than operator, the less than or equal to, the equals, the not equals, the greater than or equal to. So these are commonly used operators. Let us go on to see what we have with the false condition, false and true conditions. So when I talk about the false and true conditions, let me start a notepad here. Let us go on to see the false and true conditions. Now, why am I saying false and true, not true or false? So here is what you have. The word false in proper case is false. The word true in proper case is true. How do you know whether it is true or false? Let us go to the Python prompt. There is a function in this list of built-ins. There is a function called bool, which will tell you whether a particular expression is true or false. So let us go on to use the bool function to find out whether the expression is true or false. So I was talking about the word true. So let me give this same symbol inside bool, and this gives me true. Similarly, when I give false, it is giving me false. So now let us go on to see the other false and true conditions. 0 is false, non-zero is true. Now that non-zero may be 1, 2, 121, minus 121, any number, all these are true. Let us go on to see this for ourselves. So here I am, bool of 0 is giving me false, bool of 1 is giving me true, 2 also is giving me true, 121 is also giving me true, minus 121 is also giving me true. You could use any number there. If it is not 0, then it is true. If it is 0, it is false. If it is 0, it is false. If it is not 0, it is true. Now that we have understood the 0 and non-zero, let us go on to see what you have with 0.0. 0.0 is also false. But 0 followed by any number of zeros followed by 1 is true. So let us see this for ourselves. This is the number. I'm just copying and pasting the number for ease of working. So 0.0 is false, but when I use this number, it is true. Even though it has so many zeros, okay, it is such a small number. It is, I'm not sure if the scientific community has given a particular name like micro or things like that. So it is a very small number, but still, because it is non-zero, it is true. 0 is false, non-zero is true. If I have a string without anything in quotes, this is false. If there is nothing in quotes, it is false. If there is something in quotes, it is true. If there is anything in quotes, it is true. If there is anything in quotes, it is true. So let's go on to see this on the Python prompt. So here I am giving nothing in quotes, it is giving me false, and I'm giving something in quotes, it is giving me true. If I give anything in quotes, it is going to give me true, which means if there is anything, and that anything can include just a single space, this is also true. If there is nothing in quotes, it is false. If there is something in quotes, it is true. Now that we have understood the false and true conditions related to strings, let us go on to see what else you have with the false and true conditions. If you have nothing in square brackets, it is false. If you have something in square brackets, it is true. So let us go on to see this. So here is your square brackets. This, because there is nothing in square brackets, I may have just spaces. This is also false. Okay. But if I have something like a 0, 1, 2, 3, this will be true. This will be true. Moving forward, if you have nothing within parenthesis, this is false. If you have something within parenthesis, this is true. So let us go on to see this. So here I'm giving nothing within parenthesis, it is giving me false. I'm giving something within parenthesis, it is giving me true. Another thing which you have is the flower brackets. If you have nothing within flower brackets, it is going to be false. If you have something within flower brackets, it is true. So here we go. Let's go on to give nothing within flower brackets and then give something within flower brackets. Observe, these are all the false and true conditions. Now that you have understood the false and true conditions, the next question is, where would you use the false and true conditions? This you will use when you are having a comparison, maybe with the conditional if or with the while loop. So when you see it in a conditional or a loop, that is when you will appreciate it. So going forward, when we see an exercise and you look at the concept of the false and true conditions, you'll appreciate why the Python interpreter works the way it works. So we have seen some of the operators when it comes to comparison, when it comes to comparison operators. We saw there is less than or equal to, there is equals, there is not equals, there is greater than, and there is greater than or equal to. Apart from these operators, we have the and or. These are for multiple conditions. So this is to form a compound expression. You also have not for negation. You'll see these symbols in the list of keywords which you have seen at the help prompt. So we have seen the logical operators. We have seen the comparison operators. Let us go on to see the assignment operators. The assignment operators which we have, you have already seen x is equal to 10, which you have done. This is an assignment operator. So this is your equals operator, which is the assignment operator. Apart from this, some of the assignment operators which you have, some of the assignment operators you have, plus equals, minus equals, slash equals, star equals. So let us see what this means. If I happen to give a x plus equals 1, this is equivalent to x is equal to x plus 1. Those of you who are coming from C++ background, you can directly relate to this. X minus equals 1 expands to x is equal to x minus 1, slash equals x slash equals 2 expands to x is equal to x divided by 2, x star equals 2, x is equal to x into 2. So these are your assignment operators. Now that we have understood the assignment operators, the comparison operators, the logical operators, the negation, arithmetic operators, we have seen things. Let us go on to conditionals and loops. When we talk about conditionals, you have the conditional if. In the process of exploring the conditional if, let us try and understand the general syntax. It takes the form if condition colon after an indentation is part of the syntax. After an indent, you have to give the set of state. After an indent, you give the set of state. When you're working with Python, you don't really have to use parentheses here. Unlike the C programming language where your structure would look like this, the conditional if, the structure would look like this. Here, this is the structure. You don't use this as a structure. This is not permitted here. Parenthesis is optional. If you give it, it's fine. If you don't give it, it's fine. Python is not expecting parenthesis, but when you give it, because of the BODMAS rule, the bracket of the BODMAS rule being the parenthesis, it is going to allow you to use the parenthesis, but it's going to remove the parenthesis and evaluate the same. Flower brackets. The flower brackets, what you're seeing here in C, C++, Java, does not exist in Python. One of those challenges which people face when they're working on development is they would want to write the code. They have written the code. Now they think for a long time before they submit the code to the code base. This is basically because they are worried of the stinkers they may get from the code reviewer. You have not indented the code, your indentation is incorrect, all this kind of stuff. In Python, you will not face such challenges because if your code is not neatly indented, your code will not work at all. Your code will not work at all in case you have not indented. Colon is part of the syntax, and indentation is the only way to indicate a block of code associated with a construct. Let us go on to see an example of the if with the elif and the else. When you're talking of the conditional if can take, you can check multiple conditions with elif. In case you choose to, you may have a else, and this else does not have any condition. So when you're working with this, what are the things you'll have to keep in mind? elif is part of if, else is part of if, else is optional, always at the end. elif is optional, always between the if and else. Again, else being optional, elif should always be after if because it is connected to this if, and it is used to check for multiple conditions. It is used to check for multiple conditions. Let us move on to take the next step. Let us go on to write a simple Python script. Let us call this as dayofweek.py. We are trying to accept the day of week, and based on the day of week, we want to display the timings of the organization. We want to display the timings of the organization. Accept the day of week. If day of week is anything from Monday to Friday, display timings 9 a.m. to 6 p.m. 9 a.m. to 6 p.m. If it is Saturday, what do? If it is Saturday, display timings as 9 to 1. If it is Sunday, display holiday. If it is Sunday, display holiday. Now we are writing a script to implement this. To accept the day of week, we will use the input function. So let's call this as day of week is equal to input, enter the day of week. Now that you have accepted the day of week, what should you do? If day of week is equal to Monday, day of week is equal to Monday. Note that Monday is a string literal here. It is not a variable. You have not stored the value into any variable. So what do? You just indicate in quotes. Otherwise, this will give you a name error. If day of week is equal to Monday, or day of week is equal to Tuesday, you don't really have to complete the entire stuff as long as you understand how to use the OR operator. So here we are supposed to display timings as 9 a.m. to 6 p.m. So here I come and I give a tab and I do a print timings 9 a.m. to 6 p.m. Timings 9 a.m. to 6 p.m. Now let's go on to give the elif here. Elif day of week is equal to Saturday. Timings is 9 to 1. Let's also take care of Sunday. Elif day of week is equal to Sunday. Sunday is a holiday. So let's type holiday. Let's type holiday. Okay. If you choose to, in the else part, you can give invalid day of week. Print invalid day of week. Now, let us see what you have here. I'm executing the script. I give Monday. It gives me 9 to 6. I re-execute. I give Saturday. It gives me 9 to 1. I give Sunday. It gives me a holiday. If, let us say, I choose to give my name, it says invalid day of week. Now, this is looking good. Let us do something. Let me type Monday. Observe that it is giving me invalid day of week. Why? Because Python is case sensitive. Here, it gave me timings as 9 to 6 because I give Monday in proper case. Here, I give Monday in lowercase and it is giving me invalid day of week. Now, let us see the false and true condition here. Let me just modify this piece of code and I give if day of week is equal to Monday or Tuesday. So when I have this, let us see what happens. I execute this and I am entering Sunday. It is giving me 9 to 6. Why? Because a string literal is becoming true, permanently true, because you do not have a complete expression here. You just have a string Tuesday. The string Tuesday, as we know, according to the rules which we have seen, the false and true conditions, is permanently true. That is the reason why it is showing you, even when you entered Sunday, it is giving you 9 to 6. So we have seen how to work with the conditional if. You can have if. The if needs to have a colon. And when you're talking of the indentation, the indentation has to be the same throughout, meaning this indentation and this indentation should be the same. Let us see what happens if the first indentation is a tab and the second one is spaces, but on it is spaces on the same column. Let us go on to see what happens when I do this. I'm giving, let's say, anything I give, it is not going to go beyond that. So it has stopped here. So let me make this day of week is equal to Tuesday. So when I do this, and now when I execute this, let us see what happens. So here we go. It is giving me 9 to 1. Day of week, I'm giving you Saturday 9 to 1, Sunday holiday. Okay. Here is what you need to understand. When you're working with indentation, if I have a second line right here, let us say I have a second line right here. And let us say one of them is a space, the other is a tab. Let us see what happens. It says tab error, inconsistent use of tabs and spaces in indentation. When you look at it, the two look the same, but one has spaces, the other has tabs. So please be careful. If you're using tabs throughout, use tabs. If you're using spaces throughout, use spaces only. Here is something you need to understand. When you're working on your projects, you'll be working with the IDE, and there, the moment you type in a if condition colon and hit the enter key, immediately it will give you an indent and you don't have to worry about the indent. Now, sometimes there's a question, should we use spaces or should we use tabs? What you need to understand is spaces or tabs, the choice depends on what is indicated in your coding style guidelines. Every organization will have coding style guidelines. Just look up the coding style guidelines. If the coding style guidelines is telling you that it should be tabs, it should be tabs. If it is spaces, it should be spaces. Python is okay with you having spaces or tabs. Absolutely no challenge. So we have understood that when you're working with Python, indentation is important. That is not all. When you're using indentation, you should always use the same character for indent. You can't use spaces once and tabs in another place. So now that we have seen how to work with the conditional if, let us go on to see how we can work with the while. The while loop also has a similar syntax. Let me take you to Notepad and we will write a script. Let us say I call this as numbers.py. And in the process of explaining how to work with the while loop, we will also write a program. So here is your while loop. The while loop takes the form while condition colon set of statements after an indent. So I need an indent here, and after an indent you have your set of statements. Let us go on to see what you have here. When you're talking of the while loop, as long as this condition is true, execute this set of statements. As long as this condition is true, execute this set of statements. This is what you're telling. As long as the condition is true, execute this set of statements. Let us go on to write a program to display numbers from 1 to 10. To display numbers from 1 to 10, first of all, let me use a variable. Let's call this as CTR for counter. CTR is equal to 1, while CTR is less than or equal to 10. So as long as the value of CTR is less than or equal to 10, we would like to keep displaying the number. So if I happen to give a print CTR, this will display the number. But unless and until I change the value of CTR, the value of CTR will be permanently less than or equal to 10. So we will need to change the value of CTR here. I'm giving CTR plus equals 1. So now when I save this program and execute it, observe it is displaying numbers from 1 to 10. When you're working with the while loop, because it's a loop, it is going to iterate, it is going to continuously repeat a set of statements again and again and again, as long as the given condition is true, as long as the given condition is true. When you're talking of the conditional, you had if condition colon set of statements. As long as the condition is true, it is going to execute that code once. Whereas with the loop, it is going to execute again and again and again and again till the condition does not become false. When the condition becomes false, that is when it will stop. When the condition becomes false, that is when it will stop. Now let us move on to see what you have with breaking out of the loop. Let us say I give if CTR is equal to 5, break. This will break out of the loop when the condition becomes 5. So let us see what you have here. Now it is only going to show you 1, 2, 3, 4. At 5, it breaks out of the loop. 1, 2, 3, 4. At 5, it breaks out of the loop. This is breaking out of the loop. There is another loop control statement, and that is continue. For us to work with continue, let us do something. Let us move this. Let us move this below here. Let us move the print below. Why? Because when you're talking of continue, continue takes control to the beginning of the loop. Continue takes control to the beginning of the loop. So now what we'll do is, let us just initialize this to 0. And now I'm giving continue. Let us see what happens now. So now it will start from 1, go up to 11. That is not all. It is also not printing the number 5. It is not printing the number 5. What happened here? Because you gave continue, it skipped all the statements below this continue. If it does not encounter the continue, that is when it executes the statements after the continue, not otherwise. When you're working with while, the Python programming language offers an else block with a while. Let me give else print, let us say, after the while loop. After the while loop. Okay? I'm giving after the while loop. So now I'm executing this. Observe that it is also printing this. So now you may have a question, what is the use of the else block? Let us just delete the else block and unindent. And here we see, even if you did not have the else block, the behavior of the code is the same. Observe this, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11 after the while loop. Here also 1, 2, 3, 4, 6, 7, 8, 9, 10, 11 after the while loop. So now the question is, what is the use of the else block? So let us get back our else block here. And now what I will do is, I will bring in break. I will bring in break and execute it. Observe, after 4, it has broken out of the loop. And after it breaks out of the loop, it is not printing the after the while loop. Let us try and understand why. This else block is part of your while loop. This else block is part of the while loop. As else is part of your while loop, what happens here is, in case it breaks out of the loop, and because else is part of the loop, it breaks out of this also. If it does not encounter break, because else is part of while, this piece of code gets executed. So we have understood how to work with the while loop. Now when you're working with the else block in a loop, you don't find it in other programming languages like C, C++, Java. So you'll need to understand, when would you use this? You will use this when in other programming languages where you have used the flag variable in a loop, and then you have checked out what is the value of the flag variable, and based on the value of the flag variable you have done something. Here you don't need to worry about creating the flag variable and then after the loop checking if the flag variable is set or otherwise. Here you can work in this form where in the else block you are writing a set of statements which will get executed if and only if the while loop is not encountering the break. In case the while loop encounters break, it does not go to the else block.